So what we're going to do in this video is take a look at how we can start using Maple, particularly to produce three-dimensional graphs. Maple does a lot of things. In fact, I would encourage you to play around with it when you get a chance. But for today, we're going to concentrate on how it draws graphs. When you open Maple, you should get a startup screen that looks like this. You're going to want to select a new document to begin your work. Now, just to get in a good habit, when you create Maple documents to hand in to me, they're going to need to be organized and labeled so that I can follow your work. Up here in the corner, Maple has two options, text and math. When I'm just typing words, text, I want it in the text designation, and then I can say, using Maple to graph. And that can now be like the title of my document. Notice it has word processing features over here. I could make it bold or underline it. I could change the color, all those usual things that you can do when you are typing in text. So it just becomes a very fancy word processor at this point. All right, I'm going to change it back into math now. And now I'm actually going to start doing some math. So the first thing I'm going to do is say, hey, if I'm in a graph, I want all of Maple's plotting commands available. Maple is such a huge program. All of its commands aren't available all the time. It just makes it run faster and more efficiently. So if I know I'm going to want to use the plotting features, I'm going to tell it that by typing with, and then in parentheses, plots. And there we go. Everything that was listed here are all the features that are now available to me in Maple that weren't available before I typed that command. If you don't really want to make your document messy by having it show you that big long list every time, you can type the with plots with a colon after it. It still makes all the features accessible. It just doesn't list them, and it keeps your document a little bit cleaner. All right, I'm going to space that out a little bit, and I'm going to go back to text, and I'm going to label my next section. I'm going to say two-dimensional graphs. And again, maybe I'll just format that a little bit. And then I'm going to say, okay, great, that's all I want in text. I'm going to go back to math again. Let's go ahead and draw a two-dimensional graph. To do that, we give Maple the command plot. And I'm going to graph y is equal to x squared plus 2x. So x squared plus 2x. I'm just using the little caret key above the 6 to get the squaring. Alternatively, over here in the expressions box, I could have used this little a to the b power. So if there's something you don't know a shortcut for or can't figure out, look over in the expressions box and it probably has what you need. All right, just like on a calculator, I have to set a graphing window. I'm going to say let's let x go from -5 to 5. So I said x equals -5 ... 5. That's how you set a window in Maple. And there we go, it draws us the graph. All right, a couple things about this. Notice I didn't get to control the y-axis at all. I didn't get to tell it how big to make the y-axis. And for right now, this is really only good if I have an equation in the form y equals something. If my equation is not solved for y, or if I want to be able to control the window on the y-axis, I can use the implicit plot command. So implicit plot, let's just graph x equals y squared. Okay, not solved for y, so it's an implicit function. Maple's fine with that as long as you tell it implicit plot. And I'm still going to have x go from -5 to 5, but this time I also get to say y goes from -5 to 5. And there we go. There's our implicit plot of the function. Right. Not really a function. I guess it doesn't pass the vertical line test, right? All right. You can do things to make these graphs fancier, and I will let you play around with that when you want to. Before I leave the two-dimensional graphing there, let me show you one other thing, and this is true for every command in Maple. Let's say that I wanted to play with this a little bit. I wanted to do something special with it, but I couldn't remember all the different things I can do. If you come over here and just put your mouse above implicit plot and right-click, you'll get an option to get help. on that particular command. So help on implicit plot. It brings up a new window, and I won't read this all with us now, but notice it's got a whole bunch of information and even some examples about plotting with implicit plot. That help feature is available again for every command. All right, let's do some three-dimensional graphing. I'm going to change back to text. I guess it's already there. So again, this is the kind of thing that I would be expecting you to do when you hand in assignments to me, is label your problems, call them like problem 1, problem 2. If I'm asking for explanations, turn that text feature on so that you can type explanations to me, but being able to toggle back and forth between text and math. All right, I'm now back in Math Command, and I would like to draw a three-dimensional graph. For all of the reasons that I already mentioned, I really prefer the implicit plot command. You can use a plot, in this case a plot 3D, but only if your equation is solved for z. It's in the form z equals. Usually my equations won't be, so I almost always like to use implicit plot 3D. The first one that we did in our notes was x equals 2. That gave us that vertical plane. So let's do x equals 2. I'm going to say negative 8 to 8 from my window on x, on y, and also now on z. And there we go. There's that vertical plane like we were expecting. Now there are a couple of things here that may not be what you were expecting. The biggest thing is probably the axes. Notice that the x-axis is shown down here, the y-axis there, and the z-axis here. This axis style is called boxed, but it's not what we're used to seeing. We're used to seeing the axes drawn so that they intersect at the origin. So if you want to see what you're used to seeing, back up here in my command, after the window, I'm going to put another comma, and then I'm just going to say axes equal normal. And there we go. Our axes now are exactly the way we're used to seeing them. I can grab onto this graph, just click on it with my mouse and hold down, and I can rotate. And you can see there's the origin where the three axes intersect. Again, you can, with your mouse, just grab and rotate, turn this, and look at it from different perspectives. All right, the default is kind of this variegated color, but if you want to later be able to tell things apart, sometimes it's really handy to be able to define the color that you want. So back up in my command, I'm going to say this time, let me say color equals yellow. And now my plane has changed, so it's showing up in yellow. One last thing before I leave this x equals 2 plane. If I'm drawing graphs, and this actually works for anything, graphs, equations, anything you use in Maple, and I think I may want to refer back to them later, I can assign them a name. Before my command, at the very beginning, I'm going to call this G1 for graph 1. So I'm going to type G1 and then colon equals. The colon equals means assign the name G1 to everything after this. So it's assigning the name G1 to this plotting command. All right, let's do a couple more. Oops. And by the way, I notice this is not giving me that little bluish box. It's not slanted anymore. It changed back to text on me. I'm going to make sure I change it back to math. All right, this is graph 2, so I'm going to assign it the name G2, colon equals to assign it. And I'm going to do another implicit plot 3D. The second equation that we plotted in our notes was y equals negative 3. And I'm going to assign the same window. I'd like to see my axes as normal. And this time, let's let the color be blue. And there we go. Another vertical plane. This time here's the y-axis. It's labeled down here. So you can see it goes through y equals negative 3. And it's parallel to the xz plane, and it was graphed in blue. All right, We'd like to do one more. And for some reason, when I'm hitting enter, this thing's going into text mode. I want to go back to math mode. Just one click, thank goodness. This time I want to do our third graph, which was z equals 5, I think it was. But I'm getting a little tired of retyping this every time, since most of it doesn't change. So if I just copy it, Control C, and then come down here and paste it, Control V, I get a repeat. Now I'm going to change this one so its name is G3. This time I'll change the equation to z equals 5. And let's do this one in red. And there we go. Here's a horizontal plane. Z equals 3. You can see it's parallel to the xy plane, horizontal as we expected. All right. At this point, I've got my 3 graphs, and let's suppose that I all of a sudden say, hey, you know what, it'd be really cool if I could see those all 3 together. Because I've named them, there's an easy way to do that. It's called display. If I say display, I can call back any graph that I've named and have them all displayed on the same axes. So I'm displaying, and I still use parentheses to start my command, but I now need curly braces to make the list of all the graphs I want. G1, G2, and G3. And the braces and the parentheses. Oh, and why does it not like this? For some reason it does not. All right, sorry, I got it to display. I had to pause my recording here while I kind of figured it out. Sometimes you got to do some troubleshooting with Maple. Let me tell you what I did. It was saying it didn't understand G3, and I don't know why that is, because I've got G3 right up here, right? Sometimes, for whatever reason, Maple forgets that it's done things. A very fast way to remind it is these 3 exclamation points up here. If you hit that little button, the 3 exclamation points, notice it says execute the entire worksheet. What that does is it literally redoes everything and then it remembers everything it did. So I should have thought of that and done it right away, but there it is. That's all I did. It now displays all 3 of the planes that we graphed on the same axes. You will find, I think, that giving things names in Maple is extremely helpful. It saves you a lot of typing in the long run. All right, let's draw one more graph together. I would like to graph that sphere that we ended up with. The sphere was x squared plus y squared plus z squared equals 4. It's definitely not solved for z, so we're going to want an implicit plot, and I'm only going to do this once, so I'm going to go ahead and, well, actually, you know what, let's give it a name. Let's call it sphere, colon equals, implicit plot, and our equation. Oh, goodness. All right. It's not so bad that you see some of these things because this will happen to you too. I'm in text mode. Just saw it. I want to be in math mode. There we go. You can always tell you're in math mode. It's got that little bluish box. Let's try that one more time. I'm going to name it sphere, colon equals, and I want an implicit plot, 3D, and then my equation, x squared plus y squared plus z squared equals 4. It's not a very big sphere, radius 2, so I'm just going to say let's let x go from -3 to 3, and I'll do the same for y and for z. I kind of like my axes to be normal. And for right now, I won't define a color. I'm going to leave it just like that. All right, there's my sphere. Now there's a couple of things that I wanted to show you about this. First of all, you notice how it doesn't, I mean, Kind of looks like a sphere, but it's a little bit not rounded. You've got kind of those funny sharp corners here and there. That's just a matter of Maple not having evaluated it at enough points. So I can add on to this, I can say comma, num points, or number of points, and let's do 1,000. Okay. That definitely smoothed it out some, although it might look just a little bit cornery to me still. What if we make it 2,000? Okay, and now you're really starting to see it look like a nice smooth sphere. So if your graphs are coming out a little jerky, try increasing the number of points plotted, and you'll see it better. There are a couple of other things that I wanted to show you here. If you don't like having all of those sort of connect the dots types of points all over your graph, you can tell it what style you would like. There are a whole bunch of style options which you can use the help to explore, but I'm going to say style equals surface. Whoops, and I didn't get my equal sign in there. Try that again, style equals surface, there we go. And notice now I'm seeing just the surface of the sphere. It's almost like it's got a little light source over here. The shading helps us to see what's going on. You can add a color if you want. I can make it green. It's still a surface, but now it's a green surface. And of course, as soon as I've made a surface, I can't see inside of it. So I can no longer see the axes inside the sphere. If for some reason I want to, I can define the transparency. And if you pick a number smaller than 1, like I'm going to go 0.2, I can now start to see through it. And notice how the axes are now visible. I'm seeing through the surface of that sphere. So just a few different things that will turn out to be useful to us in our three-dimensional graphing. I encourage you to play around with graphing on Maple when you get a chance. It does a lot of things that are very, very helpful. We've just scratched the surface here.